Okay, so law of sines, not too bad, right? Well, when we get to this other case, given side, and the non-included angle case, some people call this the ASS case, ASS case, if you read it backwards. Okay, be careful. We're going to see some kind of strange things occur. So let's look at this example. Okay, here we are again having a given side. Let's say given side A included, given side B included, and the non-included angle A. Okay, that's the that is the SSA case, or the other way around. You could say, okay? So here's the deal that you need to be aware of. It's depending on the length of side A, the pink one, that's opposite angle A. There are several different things that could occur. We have 4 different scenarios that could happen. What if A isn't as long as the height of this triangle? What if A is short like it is here on this pink one? It's not going to be enough to close up and even form a triangle. So case 1, we could have no triangle in the first place. Okay? All right, next. What if A was exactly the same length as the height here, and so A would come straight down here and you'd have a right triangle, okay? So you could have a right triangle. Okay, that's kind of interesting. Or let's say A is pretty long, okay? Let's say A is pretty long and it comes all the way out here, okay? And so the triangle that is formed looks a little something like this, okay? So we could have, in that case, we could have, I don't know what color to write that in. We could have one triangle, okay? Now, what if, here's kind of like where it gets really interesting. What if A was just the right amount long? Okay? Let me say A maybe comes to be about right here. Okay? Let's say that's what side A looks like. Well, if that happens, you could have this triangle that would look a little something like this. And at the same time, I'm going to draw in another same length of side A here, but what I could swing it back this way. I'm trying to draw the exact same length of side A. And now what is formed, okay, wrap your brain around this, people. Now what is formed is another triangle with given side B, given side A, and the non-included angle, angle A. So you could have 2 different triangles if A was just the right length, okay? You would have this, I moved the wrong thing. Okay, if A was just the right length, you would have the green triangle, which we'll talk about what that is, or you could have the yellow triangle. I didn't draw the whole thing. I left part of it over there. I'll just leave it here, okay? So what happens is, what 2 types of triangles do you get here? You get 2 triangles, okay? One is going to be acute. You're going to have one, I don't want to put a comma there. You're going to have one acute triangle, and you could possibly have, look at what type of triangle this would be. You would have one obtuse triangle. Okay? So these are the different cases that could occur given that ambiguous case, side, and non-included angle. It sums it up in the purple box. You could have no triangle. That's the first case. And that if A is too short, okay, to come down there and touch side C. You could have one right triangle if A is exactly the altitude of that triangle. You could have one oblique triangle, okay? One triangle there if A is just long enough, okay? Or you could have those two triangles that we talked about with that same given side length A, okay? You could have the acute triangle here, and you could have the obtuse triangle here. So the thing is we're always going to see if this occurs. We're always going to check that out and see if that happens. All right? And we'll be able to determine whether it does or not. Now, pretend like you don't know what the title of that is. Okay? And this looks like just anything else where we are going to solve the triangle. So I'm going to draw me a little reference triangle. Okay? Let's see. I've got side B is 5. I'm going to write my givens here. Side B is 5. That means this guy down here is angle B. I'm going to label it that way. Angle B. Let's see. Side C is 12. That means angle C is opposite that, and that's actually given to us to be 73 degrees. Okay? So what is missing is angle B, okay? And also angle A would be down here, and its other side, our third side, side A. Okay, so that's what's going to go in our box. Angle B, angle A, and side A. All right. Now, let's see. Do we have a pair of angle and its side opposite? Yep, right there. Okay? And so we're going to be saying that the sine of 73 degrees is to its side opposite 12. The sine of angle C is to side C as, okay? Now I'm going to have to use angle B with side B. I don't know what angle B is. There is my unknown, okay? But I do know side B is 5, okay? Now, when we go to clear out our fractions here by multiplying both sides by 5, okay? What we've got going on here is the sine of angle B. That is going to be equal to 5 times the sine of 73 degrees divided by 12. Okay? Now, I'm trying to solve for angle B, and so remember what you do to get that sine off of there. You take the inverse sine of both sides. Okay? So, the inverse sine of 5 times the sine of 73 degrees divided by 12 is going to be equal to the measure of angle B. Okay? So, let's go to our calculator and let's see what that is. Now, what I might want to do here is go ahead and get what this number is. Because recall, if this quantity in here ends up being greater than 1 or less than -1, you're not going to have an angle that has a sine value of something greater than 1 or less than -1. That would be the case where you have no triangle. I don't know. Let's see. Okay? So I'm going to take 5 times the sine of 73 degrees. All right, I'm just going to go ahead and enter that and then say, what's that divided by the denominator? 12. Okay, so we've got 0.398. That is in between -1 and 1. Okay, 0.3984. Let me go ahead and let me jot that down. We're not done yet here, okay? But what we've got so far, This number in here was about 0.3984 and then some stuff. I can't remember. Okay? And here you want to see if, okay, not only do we have one triangle, now would we have two triangles? Well, you know that sine is positive, could be a positive 0.3984 for angles in quadrant 1 where sine is positive, as well as quadrant 2 where sine is also positive. Okay? So this is where we're checking to see if we have possibly two triangles. Okay? If we have an acute triangle, and if we also have an obtuse triangle. Okay, we're going to see that. So, let's see what angle in quadrant 1 has a sine value of 0.3984. So I'm going to say what angle has a sine value of, so inverse sine of that last number. I don't want to have to punch it in, so I'm just going to say that last number. Okay. 23.5 degrees. Yeah, let's just go to one decimal place for the angles as well, I guess. Okay, so 23.5 degrees. That's the acute angle. Now, to get over here for quadrant 2, I'm going to say 180 minus the 23.5. And that's how we get the angle in quadrant 2 that has a sine value of 0.3984 as well. Okay, so let me jot those down. Then we're going to see if those are going to work out for us or not. Okay, we have 23.5 degrees. And we also had 156.5 degrees. For quadrant 2, 156.5 degrees. Okay, those are two choices. So let's go put those in by angle B. 23.5 degrees, that's choice 1. And is it also possible for us to have angle B of 156.5 degrees? Now, this is only the one triangle, because for any triangle, the sum of all the interior angles is 180. And when we take this 156.5, which is what's in question, if that exists or not, and add it to 73, we get something that's greater than 180. Okay? So the 156.5 plus the 73 degrees is actually too big, 180. It's greater than 180. So no obtuse triangle. We're only going to have to focus on finding the acute triangle. Okay? So we're going to go ahead and we're going to take that off of there. 156.5, no for you. Okay? But angle B can be 23.5. Okay? Now, if angle B is 23.5, we can now find angle A. Okay? Angle, whoa, too big. Angle A is going to be 180 minus the 73 minus the 23.5 degrees. And that is actually going to give us 83.5 for angle A. Okay? Angle A is going to be 83.5 degrees. Okay, over here, 83.5 degrees. And now that we have angle A, we should be able to find the last thing that's missing, and that is side A. We're going to have to use the law of sines to do that. Y'all, remember that we don't have a right triangle, so we can't use the Pythagorean theorem, okay? This is not a 5, 12, 13, okay? That's only for right triangles, so don't make that mistake. What we can do is use the law of sines to find side A, So here we go again. I'm going to use the